So fourth graders, as you can see today we're combining two lessons. We're doing Module 5, Lesson 5, and Lesson 6, okay? Because these are two lessons that fit really well together because they are both about using area models to decompose fractions. You can see we're mixing together and combining and extending everything we've learned about before. We learned about area models before, and we also learned about decomposing fractions. And we're going to see how those two things can fit together. In the problem of the day, we saw that there are different ways we can use fractions to represent the same amount. You knew that because you could say that 1/2 is the same as 1/4 plus 1/4. Remember that? Okay. So we can use area models, or pictures of rectangles, really, to prove that two different fractions are exactly the same. For example, 1/5 and 2/10. Are those numbers the same or different? 1/5, we have 1 and 5. 2/10, we have 2 and 10. Are those numbers the same or different? Everyone? Same. What? Is 1 the same as 2? Is 5 the same as 10? Are the numbers themselves the same or different? Different. But how come you all said the same? Talk about it at your table groups. You can see here that we have 1/5 of the entire piece of tape shaded in. Yes? Or the entire rectangle. Now, what happens if I cut a line through it like this? Do I still have 5 equal-sized pieces? Do I still have 5 total equal-sized pieces? No. How many equal-sized pieces do I have now? Everyone? 10. You can see that I have 1, 2, 3, 4, 5 on the top, and then 6, 7, 8, 9, 10 at the bottom. That means that one section now is what fraction of the entire thing? What is my unit size? Vani? 1/10. Very good. So that's 1/10, this is 1/10, this is 1/10, etc. Right? So if I had 1/5 shaded in now, how many sections are shaded in now total? This is 1/10 and this is 1/10. How many sections do I have shaded in? Everyone? 2. So here's 1/10 and here's 1/10. So 1/5 then must be equal to 2/10. Because this is 1/10 and this is 1/10. So what this means is that we can decompose 1/5 because we know that 1/5 is equal to 2/10, which is the same as 1/10 plus 1/10. So I can write it using addition to decompose it like this: 1/5 equals 1/10 plus 1/10. Or I could also write it using multiplication by saying that 1/5 is equal to 2 copies of 1/10. See how we used an area model to decompose the fraction of 1/5? Very nice. Let's try it again. Currently in the given drawing, the rectangle shows fifths, but we want it to be 15ths. So how can I draw horizontal lines to make it 15ths? If I draw one horizontal line, do I have 15ths? What size units do I have? 10. Everyone? 10. So that's not going to work. I need 15ths. So how many rows do I need in order to make it 15ths? Show me with your fingers. Anushka, tell me more.
Because the 5 times 3 is
5 times 3 is 15. So if I make there be 3 rows, would I have 15 equal-sized units? So now I have 15ths. So that means that this one section right here is 1/15. Do you guys agree? Now, how many 15ths then are shaded in? This is the part that's shaded. How many 15ths are shaded in? Sachi? 12. So I can show that I have 12 15ths that are shaded in. That means that 4/5 is equal to 12 15ths. 4/5 is equal to 12 15ths because the same amount was shaded in. But it's asking me to write it as a product. So how can I write 4/5 as a product of unit fractions? It would be 1/15 plus 1/15 plus 1/15 plus 1/15. How many times? Everyone? So how do I write that as a multiplication sentence? Sparsh?
12 times 1/15.
12 times 1/15. Very good.